Right now, a silent force carries you through the dark, at a speed your senses cannot feel. Earth spins, orbits, and drifts inside a galaxy shaped like a glowing river of stars. A river so large that even light, the fastest thing the universe has ever known, needs 100,000 years to cross it. Beneath your feet, the world hums with life. Above you, space stretches into a quiet so deep it swallows sound itself. Every star you see at night belongs to a single cosmic city we call the Milky Way. A city built from hundreds of billions of suns, each wrapped in their own storms, worlds, and histories. Yet this city is not the endless empire we once imagined. Its vast arms do not stretch forever. Its boundaries do not reach into the infinite. Scientists have revealed a truth far stranger, a truth that makes our entire galaxy feel smaller than anyone expected. Picture yourself standing in a quiet field under the night sky. The air is still. The horizon glows with the faint silver band of starlight arching from one end of the sky to the other. That glowing band is not fog or cloud. It is the spine of our galaxy seen from within, a thin sliver of the spiral arms that wrap around us like a celestial tide. For centuries, humans believed this tide stretched across unimaginable distances, that our galaxy was too large to truly grasp. 100,000 light-years across, 600,000 trillion miles wide. Numbers so overwhelming they became symbols, not real distances. But the truth, uncovered through new measurements, is more unsettling than the size itself. Because understanding the galaxy's true width forces us to confront our place inside it. A place smaller, quieter, and more fragile than we ever believed. Imagine looking at a city from the top of a skyscraper. Streets stretch outward like glowing threads. Towers rise and vanish into the haze. Now shrink that city until it becomes a single grain of sand. Place that grain on an endless shoreline. Then learn that the beach contains 2 trillion more grains just like it. This is our galaxy's place in the universe. Not a giant. Not a colossus. Just one among trillions. Yet even as its size shrinks in our minds, the galaxy itself remains overwhelmingly vast to us. From our small vantage point, Earth sits 30,000 light-years from the center, orbiting in a quiet lane between brighter, denser arms. Here, the stars are spaced like far-flung outposts. The nearest sun lies 4 years away, across a stretch of emptiness so deep that starlight crosses it only with patience measured in ages. Within this void, the Milky Way breathes. New stars ignite in clouds that glow with the faint fire of forming suns. Old stars fade, shedding their outer layers into space. Supernovae explode in catastrophic flashes, filling the galaxy with the elements that form planets, oceans, and living beings. Every moment, cosmic events unfold that we will never witness firsthand. Clusters shift. Gas drifts. Dark matter sculpts invisible pathways through the galactic disk. We move through this structure like a single cell floating through a vast organism. And yet, despite its grandeur, a strange realization emerges. The galaxy is not a massive, endless realm. It is only the first step on a cosmic staircase that rises into distances our minds cannot follow. Look up at the night sky. Every shining point belongs to our own galactic home. Every cluster, every cloud, every glowing patch. They lie within a city we once thought impossibly large, but now know sits among countless others. And that knowledge reshapes everything. Because if our galaxy is small, if our grand cosmic home is simply ordinary, then the universe is far more immense than we ever imagined. We stand on a world circling an average star, tucked inside a spiral arm, drifting within a stellar system that does not even illuminate 1/trillionth of the galaxy around it. The Milky Way, once the boundary of human imagination, becomes something else entirely. Not the whole story. Not even a major chapter. Just a single page in a book with no clear end. And this realization carries weight. Cosmic weight. The kind that quiets the room around you and slows your thoughts until you can feel the scale pulling at your mind. Because if our galaxy is smaller than we thought, then everything beyond it must be larger than we can bear to understand. As we drift under this quiet sky, a question begins to form. A question that hangs like a distant star on the edge of perception. If our galaxy is just one grain among trillions, then what does that make us? The universe waits for the answer. The journey through our galaxy begins in darkness. A darkness so complete that only the distant pulse of starlight breaks it. Everywhere you look, suns drift through space like lanterns in an endless night. Yet the farther you travel from Earth, the more this familiar light begins to thin. The Milky Way is not a solid city of stars. It is an ocean, vast, cold, and mostly empty. A place where distance becomes the true ruler of reality. From star to star, the gaps stretch so wide that even light takes years to cross them. Imagine a world where silence replaces sound, where the nearest warm glow lies trillions of miles away, where nothing stands between you and the infinite except the faint hum of cosmic radiation. This is the true landscape of our galactic home. The nearest bright star you see in the night sky shines with deceptive closeness. It cuts through darkness like a beacon. But that star is not a neighbor. It is a traveler waiting on the far side of a gulf so large that human intuition fails. Light from that star left when ancient humans first shaped stone tools. By the time it reached Earth, entire ages had come and gone. This time gap reveals something unsettling. We never see the galaxy as it is. We see only as it was. Every direction holds a different moment in history, stitched together into a mosaic of ancient light. The galaxy's structure adds another layer of strangeness. It spins. Slowly. Relentlessly. Like a turning wheel made of stars and dust. Our solar system rides this wheel once every 200 million years. During the time light travels from one edge of the galaxy to the other, the entire spiral shape twists through space, shifting, warping, evolving. Even the galaxy changes faster than light can cross it, meaning our view of it, our maps, our diagrams, are always shadows of a moving target. This has consequences deeper than wonder. It rewrites the limits of communication. Radio waves, laser beams, any message carried by light faces the same barrier. Nothing can outrun the universe's speed limit. If a distant civilization exists on the far side of the Milky Way, their message would take longer to arrive than the entire history of human culture. Longer than the rise and fall of continents. Longer than the birth and death of species. A simple greeting would need patience written in geological time. A reply would need even more. The galaxy may appear unified, a glowing spiral of billions of stars, but it is not a single connected community. It is a patchwork of isolated regions separated by oceans of time. Each region follows its own path, unaware of events unfolding thousands of light years away. The stars you see tonight may have changed since their light left. Some may have moved. Some may have erupted. Some may no longer exist. The night sky is not a portrait. It is a relic. Even the emptiness between stars deepens this isolation. To visualize it, imagine shrinking the sun to the size of a simple basketball. At that scale, Earth becomes a grain of sand 26 feet away. And the nearest star? Another basketball in a completely different city. Between them, nearly perfect void. This is the architecture of our galaxy, immense spaces punctuated by tiny islands of matter. Stars drift alone through a sea so empty that individual atoms float miles apart. This emptiness defines everything, from star travel to communication to the likelihood of ever meeting another intelligent species. The Milky Way seems crowded when you gaze at the sky, but that is an illusion created by distance and brightness. In truth, our galaxy is a realm of solitude. And through this solitude, a quiet truth emerges. The boundaries of our galaxy do not confine us. Its emptiness does. Every attempt to imagine crossing these distances stretches the mind beyond comfort. Even a spacecraft traveling at the speed of light, a feat impossible for matter, would still need years to reach the nearest stars, decades to reach clusters, centuries to cross small regions of the galaxy, eons to reach its farthest edges. Most of the Milky Way will remain forever beyond our reach. Not because we lack technology, but because the universe itself sets the limits. Yet this limitation leads to a deeper revelation. If the emptiness between stars feels overwhelming, then what waits beyond the galaxy must dwarf everything we know. Beyond the faint glow of our spiral arms lies a darkness even greater. A darkness where the distances between galaxies stretch so wide that even the void between stars seems crowded by comparison. And within that greater darkness, the next chapter of cosmic scale begins. Beyond the quiet vault of our own spiral arms, the universe deepens into something far more overwhelming. The Milky Way, already vast beyond human experience, becomes only the first rung of a ladder that climbs into distances no mind evolved on Earth was built to understand. Look toward the faint smudge of light in the constellation Andromeda on a clear night. It appears harmless, small, almost delicate. Yet that dim blur is another galaxy, a titan of over 1 trillion stars, stretching more than twice the width of our own. A galactic continent drifting through the dark. Its light began its journey when early humans still shaped stone tools in the dust. Every photon we see from it tonight is ancient, older than language, older than history. What you see is not Andromeda as it exists now. It is Andromeda as it once was, a ghost from a time long vanished. This is one of the strangest truths of the universe. The farther we look, the deeper into the past we fall. Space is a time machine, and light is the slow messenger carrying its stories across the void. But then comes the revelation that reshapes everything. That shimmering neighbor, that giant of 1 trillion suns, is not drifting away. It is coming toward us. At 250,000 miles per hour, Andromeda races across the cosmic sea. In 4.5 billion years, the two largest galaxies in our region will meet. Not with the violence of crashing worlds, but with the slow, graceful merging of star systems gliding through vast, empty space. Galaxies collide the way clouds drift through each other. Stars almost never touch. The distances between them are too immense. But gravity will twist both spirals into a new shape, an enormous elliptical galaxy glowing with the combined light of trillions of suns. The Milky Way will not die in this encounter. It will transform. Our sun will likely survive the dance, carried into a new orbit in a newly formed cosmic city. The night sky of whatever worlds exist then will glow with strange patterns, unfamiliar constellations born from the merger of two once separated realms. Yet this galactic collision reveals something deeper than future spectacle. It exposes the scale of the dark ocean surrounding us. For Andromeda, our nearest major neighbor, lies so far away that its ancient light needed millions of years to reach our world. And beyond Andromeda lies more darkness, more void, more galaxies drifting at impossible distances. The space between galaxies is not merely empty. It is emptiness raised to another order of magnitude. Temperatures hover just above absolute zero. Atoms grow rare. Radiation spreads so thin that a cubic meter of intergalactic space may contain only a few particles. This is the realm that surrounds our galaxy, a realm so vast that the Milky Way itself becomes a small island in a silent cosmic sea. Yet islands seldom drift alone. Galaxies gather into families, gravitational collectives called galaxy groups. Our own belongs to the local group, a neighborhood of more than 50 galaxies bound together by forces too slow for human eyes to witness. Around us drift small dwarf galaxies, faint companions that orbit like distant moons. Some are so dim they remained hidden until modern telescopes revealed them. Some are torn apart by our galaxy's gravity, their stars stretched into long streams glowing faintly across space. This quiet cannibalism has continued for billions of years. The Milky Way grows not just through star formation, but by drawing in its smaller neighbors. Galactic tides reshape them, dissolving them grain by grain across cosmic time. Yet even the local group, a region spanning 10 million light-years, remains tiny on the next step of the ladder. For our group is only one member of a much larger assembly, part of an immense structure that bends space itself. A cluster so powerful its gravity governs the motions of thousands of galaxies. The Virgo cluster lies 54 million light-years away. A realm so dense with galaxies that the night sky there would burn with hundreds of suns where we see only a few. Its gravitational pull reaches across millions of light-years, tugging on our entire local group like a distant tide. But here lies another unsettling truth. Galaxies within clusters move at speeds so high, millions of miles per hour, that they should have scattered apart long ago. Visible matter alone cannot hold them together. Something unseen binds them. Something invisible yet massive. Dark matter forms a hidden skeleton beneath every cluster, a web of gravity that shapes the universe on scales we cannot touch. We cannot see it. We cannot hold it. But we see its fingerprints everywhere, in the bending of light, in the motions of galaxies, in the structure of space itself. Clusters, filaments, superclusters, these are the bones of the cosmos, the framework upon which galaxies arrange themselves. And the Milky Way occupies only a single point along this grand architecture. As we climb outward from our spiral home, the scale grows more immense with every step. Distances balloon from thousands of light-years to millions, then to hundreds of millions. The universe becomes a three-dimensional web where galaxies are the glowing nodes, connected by threads of dark matter stretching across unimaginable distances. The next time you look up at the night sky, remember this. Every star you see belongs to just one galaxy, and that galaxy is only one among trillions. One drop in a rising ocean of cosmic structure. And beyond these structures, beyond clusters and superclusters, lies something even larger. Something that reshapes our understanding of existence itself. The next step takes us deeper into the cosmic web. Step back far enough from the Milky Way, and its spiral arms begin to blur. Step back farther, and even the local group fades into a faint cluster of lights. Keep moving outward, and a breathtaking pattern emerges, one of the most astonishing structures ever discovered. The cosmic web. A vast, interconnected framework stretching across billions of light-years, woven from galaxies, gas, and invisible dark matter. A structure so immense that every map humanity has created barely scratches its surface. Here, the universe stops looking like scattered islands of light. It begins to resemble something alive. Filaments, thin bridges of matter, stretch like glowing highways across unimaginable distances. They connect clusters the way arteries link the organs of a vast cosmic body. Where these filaments intersect, galaxy clusters form, crowded with hundreds or thousands of stellar cities. Where they falter, enormous empty regions open, cosmic voids, silent and dark. The scale is almost impossible to grasp. Some filaments extend hundreds of millions of light-years. Some walls of galaxies span over 1 billion. Their thickness, compared to their length, is so thin they resemble sheets of cosmic glass. And through it all, gravity pulls, shapes, sculpts, slowly drawing matter toward the densest regions over billions of years. This grand design began long before stars existed. In the infancy of the universe, dark matter gathered into subtle patterns, forming the first scaffolding of reality. Normal matter fell into these invisible shapes, tracing their contours like dust outlining an unseen wind. Even now, the web continues to evolve. Galaxies drift along its filaments. Clusters merge. Regions collapse inward as others stretch apart. Cosmic expansion pulls the fabric outward, yet gravity persistently knits dense regions tighter. This delicate balance creates the universe we see today. To understand how empty the voids truly are, imagine a sphere 300 million light-years across, large enough to swallow thousands of galaxies, containing almost nothing. No suns, no planets, no brilliant nebulae, just a handful of faint galaxies scattered like lonely embers in a desert of cold space. These voids make up most of the universe. They occupy nearly 80% of all cosmic volume, creating dark bubbles between the luminous threads of the web. Inside them, temperatures plunge, density falls, and silence reigns. If Earth existed inside one, humanity might never have discovered other galaxies at all. Yet even these vast deserts are not entirely empty. Invisible filaments of dark matter still run through them, too thin to trap normal atoms yet essential to the cosmic structure. A hidden lattice within a hidden world. Now shift your gaze to the opposite extreme. Where matter gathers most powerfully, enormous galaxy clusters form, cosmic metropolises glowing with the combined light of trillions upon trillions of stars. Here the gravitational fields are so intense that they bend space itself, warping the images of galaxies behind them into strange arcs and distorted smudges. This bending of light, gravitational lensing, is one of the clearest signs that invisible mass dominates the universe. Dark matter outweighs everything we can see by a factor of 5. Without it, the cosmic web could not exist. Some regions form colossal walls, thin, sheet-like structures spanning hundreds of millions or billions of light-years. The Sloan Great Wall. The Hercules Corona Borealis Great Wall. Structures so immense they test the limits of cosmic physics. Humanity once believed the universe was scattered randomly, but the cosmic web proves otherwise. It reveals that matter arranges itself with surprising order, shaped by the invisible forces running through space. Every galaxy, every cluster, every void, every filament, all are part of a single architecture. And the Milky Way is just one glowing bead on one thread in this great cosmic tapestry. Yet, as unimaginable as the cosmic web seems, it is not the end of the hierarchy. Greater structures lie beyond superclusters, attractors, patterns stretching across hundreds of millions of light-years. Even our own home, a region called the Laniakea supercluster, turns out to be only one piece of an even larger cosmic flow, a gravitational river pulling galaxies across unimaginable expanses. We drift along this river right now, carried by forces older than stars. And as we continue climbing the cosmic ladder, one truth becomes increasingly clear. Our galaxy, once thought immense beyond imagination, occupies only the smallest corner of a universe whose structure grows ever larger, ever stranger, ever more impossible to fully comprehend. But even this cosmic web, with all its grandeur, is only one chapter in a story that reaches far beyond the limits of what we can see. Ahead lies the next revelation. A universe filled with far more galaxies than anyone ever dreamed. Aim a powerful telescope at a patch of sky no larger than a grain of sand held at arm's length. A region so small it seems empty, too small to matter. Let the telescope gather light for days, collecting every faint photon drifting across the void. When the final image appears, something astonishing emerges. Thousands of galaxies bloom from the darkness. Not stars, galaxies. Each one a vast island of billions of suns, each with its own worlds, its own histories, its own possibilities. This is the Hubble Ultra Deep Field, a portrait of the universe's hidden abundance, captured by staring into a place that looked like nothing. And from that single sliver of sky, humanity learned a truth almost too large to believe. The observable universe contains more than 2 trillion galaxies. 2 trillion cosmic cities drifting through expanding space. 2 trillion spirals, ellipses, dwarves, and irregular shapes. 2 trillion gravitational kingdoms, each with enough stars to fill imagination beyond its limits. If you tried to look at one galaxy per second, without rest or sleep, you would need more than 60,000 years to see them all. But the numbers become even more staggering. Most galaxies contain around 100 billion stars. Multiply this by 2 trillion, and the cosmic census surpasses 10 septillion, a number larger than the grains of sand on every beach on Earth. And yet this comparison still fails to express the scale, because stars are only the beginning. Modern surveys reveal that nearly every star hosts at least one planet. Many host entire families of worlds. Gas giants, icy spheres, desert planets, ocean planets. A cosmic variety beyond any imagination formed on Earth. Conservative estimates suggest that the observable universe contains more planets than sand grains multiplied by every atom in those grains. In this ocean of worlds, the chances of life emerging on only one seem impossibly small. If even a sliver of planets orbit in the right conditions, the universe should be overflowing with biological activity. Some life forms may be simple microbes clinging to alien oceans. Others might rise into intelligence. Some civilizations might be millions of years older than humanity. Some might have flourished and vanished long before Earth even formed. And yet, the night sky remains silent. Not because life is rare, but because the distances between stars, and especially between galaxies, form barriers no technology can overcome. Signals disperse. Light fades. Expansion stretches every message beyond recognition. Civilizations may bloom like brief sparks on their own isolated worlds, unaware of others burning in distant corners of the universe. Each galaxy becomes its own experiment, its own story, its own island in an infinite archipelago. The Milky Way, with its hundreds of billions of stars, feels immense to us. But among 2 trillion neighbors, it is perfectly ordinary. A medium-sized spiral with nothing remarkable beyond the fact that we call it home. Our entire local group, with its dozens of galaxies, forms less than a fraction of a percent of the observable cosmos. A mote. A whisper. A single thread in a tapestry that stretches farther than light can reach. Even more staggering. The 2 trillion galaxies we can see may represent only a small fraction of the true number. As instruments improve, astronomers discover faint dwarf galaxies, tiny clusters, and hidden structures once invisible to our oldest telescopes. The deeper we look, the more the universe reveals. Yet a paradox emerges. As we refine our observations, the universe continues to expand. Galaxies drift farther apart. Light stretches until it fades beyond detection. Regions once visible slip permanently over the cosmic horizon. A time will come when future observers may see only a handful of galaxies, all others erased by expansion, lost to the darkness beyond light's reach. The universe grows richer the deeper we look, but poorer the further we move into its future. For now, we stand at a cosmic crossroads, a moment in which telescopes allow us to witness billions of galaxies before they drift away forever. A moment in which the universe reveals its true scale. A scale that reduces the Milky Way from an unimaginable titan to a single grain of sand on an endless cosmic shore. And yet, even this ocean of galaxies is not the final measure of reality. Beyond the limits of what we can observe lies something larger still. A realm where space stretches faster than light, where galaxies vanish beyond reach, where the true size of the universe begins to exceed every number humans have ever invented. We are about to step beyond the edge of visibility, into a universe that hides more than it reveals. Beyond the ocean of galaxies, another truth rises, one stranger than distance, deeper than darkness, and more unsettling than emptiness. The universe is not drifting apart at a steady pace. It is accelerating. Something invisible is pushing galaxies away from each other faster and faster, stretching the fabric of space itself. A force so powerful it overcomes gravity on scales larger than galaxy clusters. A force so dominant it makes up nearly 70% of all cosmic content. Dark energy. Not a substance we can hold. Not a particle we can detect. Not a field we can map with ordinary instruments. It is simply there, woven into the emptiness, quietly driving the universe toward a future more lonely than anything humanity has ever imagined. At first, astronomers expected cosmic expansion to slow down over time. Gravity pulls matter together, after all. Stars attract stars, galaxies draw closer, clusters tug on one another. But the universe disobeyed expectation. Instead of slowing, it sped up. Distant supernovae revealed the truth. Their light arrived, dimmer than it should, stretched by expansion that had grown more aggressive over billions of years. This was not a gentle drift outward. It was a runaway expansion. Space itself was gaining speed. In this expanding universe, every galaxy farther than about 14 billion light-years away already recedes faster than light, not because it moves through space, but because space expands beneath it. Nothing can outrun this expansion. Not light, not information, not even the gravity of entire galaxy clusters holding themselves together. Every second, the universe grows larger. Every second, more galaxies slip across a cosmic boundary where their light can never reach us. We see them only because their photons began their journey long ago, when they were closer. Once the last of those ancient photons arrives, they will vanish forever, carried beyond reach by the accelerating flow of space. And this fate awaits nearly every galaxy we can see today. In a few trillion years, the night sky will darken. Distant galaxies will fade, then disappear, leaving only the handful bound to our local group. To future observers, the universe will seem static and empty, its true history erased by expansion. Even the cosmic microwave background, the afterglow of the Big Bang, will stretch until its wavelengths become too long to detect. The universe's own birth cry will fade into silence. Yet the acceleration continues. Dark energy does not weaken as space grows. Its density remains constant, meaning that as the universe expands, there is more of it. More dark energy, more repulsion, more acceleration. Some theories suggest this acceleration will stabilize. Others predict it will increase until it overwhelms every force in nature. First, galaxy clusters. Then galaxies. Then star systems. Then planets. Finally, even atoms might be torn apart. A scenario known as the Big Rip. If this happens, the end will not be quiet. Space itself will shred everything it contains. But even if the universe avoids this ultimate unraveling, the accelerating expansion guarantees one destiny: cosmic isolation. A universe in which nearly all galaxies lie beyond reach. A universe in which deep space grows darker with every passing age. A universe where the grand structures we map today will one day be inaccessible to any future civilization. This age, the age we live in now, is a cosmic window. A rare moment in which the universe is still visible, still connected, still filled with distant light. We stand at the edge of cosmic history, witnessing galaxies that future beings will never know existed. The accelerating expansion reveals something profound beyond its physical implications. We are living in the universe's brief moment of clarity. But even this vast expansion marks only the beginning of the deeper truth. Because what we call the observable universe is merely a bubble within something far greater. A region defined not by physical walls, but by the limits of light and time. Now we turn to that bubble, to the edge of sight, to the cosmic horizon that surrounds every observer in existence. Ahead lies the realization that the universe we see is not the universe that exists. At the edge of what we can see lies a boundary unlike anything in everyday experience. Not a wall, not a surface, not a physical edge at all, but a horizon defined only by light, time, and the speed of the universe's expansion. This is the boundary of the observable universe. A sphere centered on Earth, not because Earth is special, but because we can see only as far as light has had time to travel since the cosmos became transparent. That distance stretches 46.5 billion light-years in every direction, 93 billion light-years from edge to edge. Yet the universe itself is far older than the light we observe, and far larger than the bubble we inhabit. To understand this boundary, imagine floating in an endless ocean. No land, no shore, only a horizon formed by how far your eyes can see. The ocean extends far beyond that circle. You witness only a fraction. The observable universe is that circle. The true universe is the ocean. Everything outside our horizon exists, but its light has not had time to reach us. And with expansion accelerating, much of it never will. The cosmic horizon does something strange to perception. Every galaxy we observe occupies not the same moment, but a different chapter in time. Nearby galaxies show their more recent selves. Faint and distant ones show their childhood forms, shining from ages when the universe was young. Look near the edge of visibility, and you peer across 13 billion years of history. But even that is not the beginning. Before the universe became transparent, before atoms formed, space was filled with a hot plasma that blocked all light. We cannot see past that era, because light could not travel freely through it. Instead, we observe a faint glow from that moment when the fog lifted. The cosmic microwave background, a radiation echo from when the universe was only 380,000 years old. That ancient light forms a spherical shell around us, a bubble not of matter but of time, a snapshot of the universe's infancy. Everything before that moment lies hidden behind a veil. We infer, we calculate, we build theories, but no telescope can look beyond that boundary. The further we gaze, the younger the universe appears. The closer we look, the more recent its story becomes. Every direction offers a different time. Every distance a different epoch. And yet, this vast sphere of visibility, this 93 billion light-year bubble, is only the beginning of the true cosmic scale. Measurements of the universe's shape reveal something astonishing. Space appears flat across billions of light-years. So flat that if the universe were small, we would detect curvature. But we do not. The implication is staggering. The universe extends far beyond our horizon, at least 250 times larger, perhaps infinitely, meaning that for every galaxy we can see, thousands, possibly millions, lie beyond sight. Entire regions, entire clusters, entire superclusters drift in realms forever separated from us. Not because they are too far in space, but because they are too far in time. If you traveled outward at light speed, you would never reach them. Expansion carries them away faster than you can chase. The universe hides more than 99% of itself behind this horizon, a truth both humbling and overwhelming. And yet there is something stranger still. Every observer in the universe, on every planet, in every galaxy, sees themselves at the center of their own observable sphere. Not because they are the center of reality, but because the horizon expands outward equally in all directions. Each observer sees a different cosmic map, a different edge, a different slice of the universe's true size. The horizon is personal, relative, unique to each vantage point. We stand at the center of our observable universe only because it is our window, not the center of existence. Just the center of what we can see. But now another layer unfolds. Because the universe not only extends far beyond our horizon, it evolves far beyond our reach. Galaxies at the edge already recede faster than light. Their present selves are gone from us forever. We witness only their ancient glow stretched across eons. And as expansion accelerates, more galaxies cross this horizon every second. More regions fade into forever darkness. More of the universe drifts beyond our sight. We live in a universe disappearing in real time. And what remains visible is only the outer shell of an even deeper mystery. A mystery that asks, if the universe is so much larger than what we can see, what lies beyond the cosmic horizon? The next revelation brings us to the answer. A realm where even infinite space may not be enough. Beyond the veil of the observable universe lies a realm we cannot see, cannot visit, and cannot measure directly, yet know must exist. A hidden expanse, where the laws of physics may shift, where space may stretch without limit, and where the familiar structure of galaxies and clusters might give way to entirely different forms of reality. This unseen territory reaches backward into the earliest moments of cosmic time, and outward into distances that may continue forever. To glimpse it, we trace clues left in the universe's oldest light and in the mathematical patterns that govern cosmic evolution. In the first minutes after the Big Bang, the universe was hot enough for nuclear fusion to occur everywhere at once. Protons and neutrons combined into the first elements. Hydrogen, helium, traces of lithium. The ingredients that would one day form stars, planets, oceans, and life. But earlier still, within the first seconds, physics itself began to change. Forces separated. Energy transformed. Space expanded at astonishing speed. Then comes a moment so strange it seems almost unreal. Cosmic inflation. A burst of expansion so rapid that regions smaller than a subatomic particle grew to cosmic scales in less than a heartbeat. It smoothed the universe, flattened it, stretched quantum fluctuations into the seeds of galaxies. and produced a cosmos far larger than anything visible today. If inflation happened, and every measurement suggests it did, then our observable universe is only a small bubble within a vastly larger structure. A bubble smaller than a speck of dust. A bubble surrounded by others. A bubble expanding inside something far bigger than our minds can grasp. And beyond our bubble may lie regions where physics plays by different rules. Where the constants of nature, masses of particles, strength of forces, even the speed of light, take different values. Some regions might never form galaxies. Some might collapse in moments. Others might flourish in ways utterly alien to our own cosmic neighborhood. But no matter how vast this hidden expanse becomes, it remains sealed off by expansion faster than light. No signal from those regions can reach us. No message can cross the boundary. Each cosmic domain becomes its own isolated universe, forever cut off from its neighbors. Yet the implications reach beyond even this. Some models suggest that inflation never truly ended. Not everywhere. New regions of space continue to form even now, budding off like bubbles in a boiling sea, each with its own physical laws, its own beginning, its own fate. A multiverse of unimaginable scale. If this is true, then our observable universe is just one room in a mansion with infinite corridors. One chapter in a book with infinite pages. One arrangement of matter among endless possibilities. An idea both humbling and dizzying. Within this structure, the universe we see, a realm containing 2 trillion galaxies across 93 billion light-years, may be smaller than a subatomic particle in the full cosmic hierarchy. Tiny. Silent. Ordinary. And just as our universe may be microscopic inside larger realms, there may be universes nested within structures so small we mistake them for empty space. Some theories propose that reality is fractal, organized into infinite layers, each with its own physics, each mirroring patterns found at different scales. Zoom outward and you find larger universes. Zoom inward and you find smaller ones. Complexity without end. The idea forces a shift in perspective. Everything we know, every star, every planet, every galaxy, may be a single layer in a vast hierarchy stretching both upward and downward into infinity. Humanity's achievements, discoveries, and histories unfold within a realm that might itself be a microscopic detail in a structure too large to imagine. And yet this does not diminish what we are. It transforms what we are. Because within this tiny bubble, matter learned to think. Atoms forged in ancient stars became beings capable of asking questions about the nature of the entire cosmos. Life emerged that could contemplate infinity from the surface of a single small world. But the mystery deepens further still. If our universe is only one region among countless others, then somewhere, across unreachable expanses, there may exist domains where space curves differently, where time flows in unfamiliar ways, where galaxies take shapes unknown to physics as we know it. And if the multiverse truly exists, then every possible arrangement of matter occurs somewhere. Worlds like ours. Worlds unlike anything imaginable. Worlds that mirror our own history. And worlds where history diverged into paths beyond recognition. We stand inside one bubble. Inside one version of cosmic reality. Inside one sliver of possibility. Yet even this multiverse, with its grand implications, is not the final boundary. Ahead lies a deeper truth. A truth hinting that our entire universe may be as small and fleeting as a spark within a greater infinity. What waits beyond even the multiverse? The next step takes us there. Shrink our entire observable universe, every galaxy, every cluster, every filament of the cosmic web, until the whole thing becomes smaller than a single atom. Now imagine that this atom exists inside a still larger universe. A universe so vast that our cosmic bubble is nothing more than a microscopic detail in its fabric. This is the scale suggested by some of the deepest theories in modern physics. Not metaphorically. Literally. If space and time come in discrete units, tiny quantum pixels smaller than anything we can measure, then the entire observable universe contains a finite number of these building blocks. A finite amount of information. A finite structure. finite things can be embedded inside larger structures. Nested, stacked, layered. In this view, our universe might not be the top level of reality. It might not even be close. Instead, it may be one layer in an infinite hierarchy. Zoom inward, and you could find universes hidden in the quantum foam beneath our feet, entire cosmic structures encoded inside the tiniest scales of space-time. Zoom outward, and you might find our universe woven into a larger cosmic architecture so immense that even the multiverse model seems small by comparison. A fractal cosmos, endlessly nested, endlessly deep. In such a hierarchy, the observable universe, 93 billion light-years across, could exist inside a structure no larger than an elementary particle from the perspective of that higher realm. And that particle could itself be part of a still larger universe. And so on, without end. Infinity above, infinity below. Some theoretical models even propose that consciousness might exist at multiple layers of this hierarchy. Large-scale minds, operating across galaxies, thinking thoughts that last millions of years. Microscopic minds, existing for tiny fractions of a second yet experiencing full lifetimes within quantum fluctuations. Perhaps our own awareness is one such layer, one expression of information processing happening in a cosmos filled with countless levels of complexity. In this view, human consciousness might be both small and vast at once. A temporary arrangement of matter capable of reflecting on its own existence, even if that existence takes place in only one tiny corner of an infinite structure. And yet, this does not diminish our significance. If reality is an infinite hierarchy, then every level matters. Every structure contributes to the whole. Every universe, large or small, plays a role in some greater pattern. Meaning does not vanish in infinity. Meaning becomes shared across all scales. But there is another implication. If infinite hierarchies exist, then versions of our universe, with nearly identical histories, must appear somewhere within those layers. Worlds with familiar galaxies, familiar stars, familiar planets, perhaps even familiar beings. Somewhere in the vastness, a universe just like ours could be nested beside entirely alien structures unlike anything we can imagine. Consider what this implies about perspective. Humanity's entire history, every civilization, every discovery, every hope, has unfolded within what may be a single detail inside a reality whose full scale outruns imagination. Yet despite this, something remarkable emerged from the chaos of cosmic evolution. Matter began to understand itself. Atoms forged in the hearts of stars, assembled into patterns that learned to question the cosmos. Dust condensed into worlds that eventually built machines capable of measuring the universe's age, mapping its structure, and contemplating its possible infinities. Human consciousness is not an accident. It is a continuation of the universe's own story, an expression of the cosmos becoming aware of its own existence. On a pale world circling an ordinary star, a species evolved the ability to look at the night sky and ask, what lies beyond? The answer may be larger than any mind can hold. A universe perhaps infinite in size. A multiverse perhaps infinite in variety. A hierarchy perhaps infinite in depth. Yet here we stand. On one world. In one galaxy. Inside one observable bubble. Trying to piece together the shape of everything. And now, with the scale of the universe laid bare, a final question rises like a distant star on the horizon. What does it mean to be human in a cosmos this vast? The final step of this journey brings us home. Back to Earth, back to our galaxy, back to the meaning hidden within the immensity. The universe, in all its unimaginable size, complexity, and age, brings us back to a single and humbling realization. Everything we have ever known, everything we have ever loved, everything that has ever existed in human history unfolds inside a galaxy that is far smaller than we once believed. A galaxy once thought to be the colossus of our cosmic understanding. A sprawling spiral of stars that seemed too vast to fully comprehend. But today we know the truth with far greater clarity. The Milky Way is not the giant we imagined. It is not the enormous, all-encompassing realm that early astronomy placed at the center of everything. It is not one of the universe's great structures. It is modest, average, a medium-sized spiral adrift in a sea of larger worlds and larger forces. A tiny island in an ocean of trillions of galaxies stretching beyond the reach of light itself. And despite its apparent immensity, the Milky Way occupies only the smallest rung of a cosmic ladder that ascends into scales no human mind can truly hold. We live inside a structure that appears enormous only because we are small. But this knowledge does not diminish our story, it sharpens it. Across 93 billion light-years of observable space, across 2 trillion galaxies, across the cosmic web and its vast scaffolding, across voids and walls and clusters, the Milky Way shrinks in comparison until it becomes a single grain of cosmic sand. Yet that grain is where everything began for us. It is the quiet place where hydrogen atoms merged to form a star we call the Sun. The place where dust assembled into planets. The place where Earth spun itself into oceans, continents, and finally life. From the outermost clusters to the deepest voids, we have traveled outward in imagination. We have seen how small our galaxy truly is. We have watched it fade into cosmic context until it scarcely fills a whisper of the universe's volume. But now the journey folds back inward, toward the story that anchors all others. Because understanding how small the Milky Way is forces a deeper reflection. If our galaxy is so ordinary, so unremarkable, then what does that say about us, the beings who learn to measure it? It says that intelligence can rise anywhere, that awareness can form in the quiet corners of space. That meaning does not come from size or scale, but from perspective. We are the witnesses of a universe too large to imagine, yet small enough for our minds to explore one concept at a time. We are the observers standing at the edge of cosmic understanding, watching as galaxies slip away, as horizons expand, as theories deepen. And though the Milky Way may be ordinary, the fact that it produced conscious beings capable of asking these questions may be extraordinary beyond measure. We return now to the heart of the story, to the question that first set this journey in motion. How small is our galaxy, really? Small enough to fit unnoticed among trillions. Small enough to fade into a cosmic tapestry spanning billions of light-years. Small enough that its total mass, its total light, its total population of stars barely registers against the universe's grand scale. But large enough to hold our sun, large enough to shelter our world. Large enough to give rise to oceans, forests, civilizations, and everything we call life. Small in the universe. Vast to us. And as the next chapter begins, we step from scale into story, from measurement into meaning. We turn our gaze not outward, but sideways, into the quiet truths and hidden wonders surrounding our own galaxy. Into the facts that reveal its structure, its purpose, its origins, and its role in the cosmic web. What we discover next does not lie in distant universes or unreachable realms. It lies right here, within the Milky Way itself. Details more intricate and more astonishing than its size alone can ever reveal. The next section opens that door. The Milky Way, despite feeling familiar in name, remains one of the most mysterious structures we have ever studied. Its true nature is far stranger and far more intricate than most imagine. Here are the deeper truths that illuminate its hidden architecture, its origins, and its place in the cosmic web. The galaxy is not a flat disk. It is warped, its edges twisted upward and downward like a vast cosmic ripple. This bend likely comes from the gravitational pull of invisible dark matter surrounding it, or from ancient encounters with dwarf galaxies long since torn apart. The Milky Way sits inside a massive dark matter halo. This invisible sphere extends far beyond the visible disk, controlling the orbit of every star, cluster, and cloud of gas within the galaxy. Without dark matter's hidden gravity, the Milky Way would fall apart. Its stars rotate too fast to be held together by ordinary matter alone. The spiral arms are not permanent structures. They are patterns, waves of density moving through the galactic disk. Stars drift in and out of these arms like cars passing through traffic zones. At any given time, the Sun lies near one of these waves, not locked inside it. Our galaxy is ancient, more than 13 billion years old, nearly as old as the universe itself. Some of its stars formed shortly after the first galaxies appeared, making them among the oldest surviving objects in existence. The Milky Way grows by consuming others. Streams of stars visible today are the remnants of galaxies torn apart by our own. In the halo above and below the disk, these stellar rivers draw faint lines across the darkness, fossils of long-lost worlds. At its center lies something extraordinary. A supermassive black hole 4 million times the mass of the Sun. It anchors the galaxy's rotation, bending space around it and shaping the motion of stars in the inner regions. Though silent from afar, it once blazed with powerful radiation when matter fell into it in ancient eras. The Milky Way is surrounded by over 100 known dwarf galaxies. Most are faint, fragile, and distorted by tidal forces. Some orbit like moons. Others are in the process of being swallowed, adding their stars to our growing spiral. The Sun does not orbit smoothly. It bobs up and down through the galactic plane every 30 million years, like a ship riding waves in a dark cosmic sea. These vertical motions may influence the environment around the solar system over geological timescales. Our galaxy is part of a vast flow of motion. Every star, every cluster, every orbit participates in a grand drift toward regions of higher gravitational density. We move not only around the galactic center, but through the local group, through the Laniakea supercluster, and toward the Great Attractor, carried by currents far older than humanity. Despite containing hundreds of billions of stars, the Milky Way is mostly empty. If you compressed all its stars with no space between them, they would fit inside a volume far smaller than the galaxy itself. What gives the Milky Way its size is not matter, but separation. Vast distances between its suns. Our location is fortunate. We orbit in a quiet region between spiral arms far from the radiation storms of the core and the chaotic collisions of dense star clusters. This calm neighborhood allowed Earth to remain stable long enough for life to emerge. Every element in our bodies, except hydrogen, was forged in stars far older than the Sun. Explosions, collisions, and ancient stellar winds enriched the gas clouds that later collapsed to form our solar system. We are not merely residents of the Milky Way. We are its descendants. And even now, the galaxy continues to change. New stars ignite. Old stars fade. Gas clouds stretch and twist. Dark matter guides their paths unseen. Over billions of years, the shape we know today will evolve into something entirely new. The Milky Way is not static. It is alive with motion, alive with history, alive with the echoes of galaxies long devoured and the seeds of galaxies yet to be born. This is the deeper truth behind the video's story. Our galaxy, once thought immense beyond comprehension, is only a small chapter in a universe of overwhelming scale. Yet it contains enough wonder, complexity, and mystery to fill countless lifetimes of exploration. And so, the journey returns to the place where it began. A single galaxy, modest in size, drifting quietly through a universe so vast it dissolves our oldest assumptions about scale, meaning, and significance. The Milky Way is small compared to the cosmic giants surrounding it. Small compared to the superclusters threading the universe together. Small compared to the cosmic web stretching across billions of light years. And immeasurably small compared to the hidden universe beyond our horizon. But within this unremarkable spiral of stars, something extraordinary happened. Matter learned to question its own existence. Atoms forged in ancient stars assembled into beings capable of tracing starlight back through time, mapping the universe, and contemplating distances that stretch beyond imagination. Here, on one planet orbiting one ordinary star, consciousness emerged. Not cosmic in size, but cosmic in curiosity. Not infinite in reach, but infinite in possibility. Perhaps that is the lesson hidden in the universe's immensity. Greatness is not measured by scale. Significance is not defined by size. The Milky Way may be small, but within it exists a story larger than galaxies. The story of life rising from dust, of minds seeking understanding, of a species daring to look outward into the unknown. We are tiny in the universe. But the universe would be silent without observers, without wonder, without questions, without the spark of awareness that allows the cosmos to understand itself. Each star in the night sky becomes a reminder. We are made of the same elements. We follow the same physical laws. We come from the same cosmic history. And though our galaxy is only a grain of sand in a universe of oceans, the meaning we create within it matters. Because meaning does not come from the universe. It comes from us. If this story moved you, don't forget to like, share, and subscribe to Cosmic Curiosity, where we explore the universe through the eyes of those brave enough to venture into the unknown. The cosmos is vast, but every story matters. See you among the stars. Across the quiet darkness of our spiral arm, the Milky Way continues its ancient motion, rotating once every 200 million years, shaping the paths of billions of stars. For most of human history, this galaxy seemed immeasurable, eternal, almost beyond study. But modern science has revealed something far more precise, far more astonishing, and far more humbling. Our galaxy is smaller than early estimates suggested. Not the towering giant we once imagined, but a mid-sized island suspended in a cosmic ocean, where far larger structures roam. This revelation pushed astronomers to rethink everything, from stellar motion to gravitational modeling, because the mass, width, and structure of our galaxy define our place in the cosmic web. The stellar disk, once believed to stretch far beyond 100,000 light-years, now appears more compact. Observations from infrared surveys, stellar parallax catalogs, and high-resolution dust maps suggest the Milky Way's luminous disk may be closer to 94,000 light-years across. Its mass, once thought immense, falls near the average for spiral galaxies seen across the universe. Our position within the galaxy offers perspective. Roughly 26,000 light-years from the center, we orbit inside a calm region of the Orion Cygnus Spur. This location shields our solar system from the chaos near the central bulge, where dense star fields, radiation storms, and the influence of the supermassive black hole reshape nearby orbits. Understanding the galaxy's true size also illuminates its life story. The Milky Way did not form all at once. Its earliest stars ignited when the universe was young, forming a primitive, compact core. Over billions of years, dwarf galaxies collided with it, their stars stretched across the sky in faint streams that remain visible today. Each collision added more mass, more structure, and more clues to the galaxy's growth. Yet the Milky Way's visible disk tells only half the story. Surrounding it lies an enormous halo made of dark matter, a spherical region far larger than the galaxy itself. This invisible scaffold may extend more than 1 million light-years from end to end, dominating the Milky Way's true gravitational boundary. Even the spiral arms, once believed to be fixed structures, are shifting patterns, density waves guiding stars into temporary arrangements. Over hundreds of millions of years, each star drifts in and out of these arms, never anchored permanently, always in motion. New discoveries continue refining the galaxy's details. Dust maps reveal hidden regions that obscure distant stars. Radio telescopes detect faint hydrogen gas tracing the outer reaches of the disk. Space telescopes uncover the warping of the galactic plane, a twisting ripple caused by past interactions with satellite galaxies. All of these findings lead to one conclusion. The Milky Way is a beautifully complex living structure, whose size, shape, and motion continue to change with time. Its smaller than expected scale does not make it less remarkable. If anything, it highlights the incredible precision with which the universe arranges matter. Every star, cluster, and nebula forms part of a delicate interplay between gravity, motion, and cosmic history. And despite its modest size compared to the behemoths of the universe, the Milky Way remains extraordinary in one profound way. It is home. A galaxy of billions of suns. A cradle for worlds we have yet to discover. a domain where life arose, learned to question, and gazed outward in search of its origins. Understanding the true size of the Milky Way does more than redefine measurements. It redefines perspective. It reminds us that discovery is not about making the universe smaller. It is about making our understanding deeper. The next section continues that journey. The Milky Way may be modest in size, but its structure holds layers of complexity that reveal how galaxies live, grow, and evolve across cosmic time. Each component, each cluster, stream, arm, and cloud tells part of a story that began more than 13 billion years ago. At the center lies the galactic bulge, a dense, ancient sphere of stars orbiting in chaotic patterns. These stars are older than the Sun, older than Earth, and older than every continent, mountain, and ocean on our planet. Their light carries memories from a time when the universe was young and galaxies were still learning how to build themselves. Surrounding this bulge stretches the galactic disk, a vast rotating plane where new stars continue to form. Here, giant molecular clouds drift like silent continents of gas and dust, collapsing under gravity to ignite new suns. These regions glow in infrared and ultraviolet wavelengths, marking the galaxy's most active birthplaces. But the disk is not uniform. It vibrates, bends, and twists as if responding to forces hidden far beyond its edge. Astronomers discovered that the outer regions rise and fall like a cosmic wave, a distortion likely caused by past interactions with dwarf galaxies that brushed against the Milky Way's halo. Beyond the disk lies the stellar halo, a nearly invisible sphere of ancient stars scattered across vast distances. Some are remnants of galaxies consumed long ago. Others belong to clusters drifting freely through space, no longer bound to the galactic plane. These stars trace long elliptical orbits, passing above and below the disk over millions of years. Farther still, beyond the reach of ordinary starlight, lies the dark matter halo. It envelops the entire galaxy, controlling the motion of every star from the core to the outermost edge. This unseen sphere contains most of the galaxy's mass, shaping its structure like the frame of a cathedral holding everything in place. The spiral arms thread through the disk, forming graceful arcs that guide the movement of stars. They are not solid structures, but patterns where gas compresses, triggering star formation. Within these arms lie the bright blue giants that burn fiercely and briefly before collapsing into supernova explosions. These blasts enrich the galaxy with heavy elements, the raw ingredients for planets, oceans, and life itself. Between the arms lies a quieter region, and it is here that the Sun drifts. Not in a dense cluster, not near the galactic core, but in a calm neighborhood that allowed life to flourish without constant cosmic disruption. The Milky Way is also a graveyard of consumed galaxies. Astronomers have mapped streams of stars, thin rivers stretched across thousands of light-years that curl around the galaxy like faint scars. Each stream marks the remains of a system torn apart by gravity, its stars reabsorbed into the Milky Way's structure over billions of years. New dwarfs continue to fall inward even now. Their orbits decay. Their stars stretch into arcs. Their gas becomes fuel for future generations of suns. The galaxy is a builder and a destroyer, growing through quiet accumulation and violent mergers, shaped by the invisible hand of dark matter. Even the Sun's orbit reflects this complexity. It does not trace a perfect circle but a gentle oscillation, rising above and dipping below the galactic plane every 30 million years. Over hundreds of millions of years, this rhythmic motion carries the solar system through different environments, sometimes calm, sometimes filled with radiation or dense clouds. Every component, from the core to the halo, reveals a galaxy still in motion, still evolving, still feeling the echoes of collisions and the promise of future transformation. And yet, despite all motion and change, the Milky Way remains steady enough for life on Earth to endure long stretches of cosmic time. It is a dynamic structure, but also a shelter. A vast engine of creation where stars ignite, elements form, and worlds arise. A place where life not only appeared, but developed the ability to question the galaxy itself. Understanding its structure is more than a scientific achievement. It is a glimpse into the forces that shaped our origins. And as we approach the final chapter of this journey, one truth becomes unmistakable. The Milky Way may be small on cosmic scales, but it is vast enough to hold every story humanity has ever known. The next section continues the descent from cosmic scale to human meaning. Across the quiet spiral of our galaxy, every star, every cloud of dust, every drifting cluster carries the imprint of forces older than time as we understand it. The Milky Way is not only a structure of matter, it is a record of cosmic history, written across billions of years in the language of gravity, motion, and light. When scientists finally determined its true scale, something subtle but profound shifted. A galaxy once imagined as overwhelmingly vast became more precise, more defined, more real. It transformed from a mythic expanse into a measurable home. A place with boundaries, layers, and a story that can be traced. This realization did not make the Milky Way smaller in wonder. It made it more personal. By knowing its size, we began to understand our place within it. By mapping its structure, we revealed how the Sun came to rest where it is. By studying its age, we uncovered the timeline that eventually led to life on Earth. Every star we see in the night sky moves with us around the galactic center. Together, we drift through space at hundreds of thousands of miles per hour, following pathways shaped by dark matter and ancient collisions. Our solar system, quiet and self-contained, is part of a much larger river of motion. Even now, as you read these words, the entire galaxy is rotating beneath your feet. Its spiral arms stretch outward like frozen waves. Its halo glows faintly with stars too distant to see. Its core thrums silently under the pull of its supermassive black hole. Yet for all its grandeur, the Milky Way is not a giant of the universe. It is not among the largest galaxies. It is not among the brightest. It is not among the most massive. Its significance comes not from its size, but from its contents. From the billions of stars it shelters, from the planets that orbit them, from the potential worlds where life may rise in forms we cannot imagine. Among those billions of stars is one modest yellow sun. Around that sun orbits a small stone planet covered in oceans, forests, and living beings capable of contemplating the structure of the galaxy itself. This is what makes the Milky Way extraordinary. Not its dimensions, not its mass, not its spiral arms, but the simple fact that within its quiet corner, one species looked up, measured its sky, and discovered the truth. We learned that our galaxy is not the center of the universe. We learned that our stars are not unique. We learned that our world is not the natural focus of creation. And yet, we also learned that meaning does not come from cosmic placement. Meaning comes from understanding, from curiosity, from the act of searching, from the fragile awareness that flickers across a small blue world, drifting through an ordinary spiral arm. The Milky Way may be small among galaxies, and humanity may be small among its countless stars, but together we form something rare. A galaxy capable of knowing itself. A universe capable of being witnessed. A cosmos capable of producing beings who ask why it exists at all. In the vast darkness between galaxies, in the cold silence of the cosmic web, in the light of stars older than our entire species, a quiet truth emerges. We matter not because the universe is small, but because it is vast. We matter because we are here to see it. And as the final chapter approaches, the journey narrows from the galaxy itself to the meaning behind it all. What these discoveries reveal about us, our world, and our place in a universe far larger than the Milky Way will ever be. From the first spark of awareness on a young Earth to the modern telescopes that pierce the edges of cosmic time, humanity has walked a path defined by curiosity. Every question we have ever asked, every theory, every measurement, every revelation, has carried us farther from the familiar and deeper into the vastness that surrounds us. And now, with everything we know, one truth shines brighter than any star in the Milky Way. Our galaxy is small, but our capacity to understand it is immense. The Milky Way drifts through a universe so large that even 2 trillion galaxies cannot express its full scale. It is only one island among countless others, shaped by dark matter, sculpted by ancient collisions, enriched by the ashes of stars that lived and died long before our sun ignited. Yet, this quiet spiral, this modest, mid-sized structure, holds within it the full history of life on Earth. Every atom in your body was once part of a star. Every breath you take carries the echoes of cosmic cycles billions of years old. Every heartbeat is timed within a universe that expands a little more each second. Through this lens, the Milky Way becomes more than a statistic, more than a measurement, more than a point in an infinite sea. It becomes a cradle, a home, a reminder that even small things can create wonders beyond measure. In the quiet of its spiral arm, the sun was born. Around it, planets formed. On one of those worlds, chemistry awoke as biology. Biology awakened as consciousness. And consciousness learned to look upward, asking questions the universe had waited billions of years to hear. We discovered that our galaxy rotates like a great wheel of stars. We learned that its spiral arms drift like waves in a cosmic ocean. We mapped its warps, its halo, its clusters, its streams, tracing the fingerprints of long-lost galaxies absorbed into its growing structure. And now we know its true size, not as a limit but as a stepping stone, a point of reference in a universe that dwarfs even our greatest mathematical imagination. The realization does not shrink us, it expands us. Because to know the Milky Way is small is to understand that the universe is far larger than fear, far larger than doubt, far larger than the boundaries we once placed around our own significance. We are tiny, yes, but we are also rare. Matter that can think, wonder, calculate, imagine, and dream. We walk through a galaxy that will one day merge with Andromeda. We orbit a star that will one day fade. We exist in a universe that will continue expanding long after our species is gone. But today, in this moment, we are here, alive, aware, witnesses to the greatest story ever told, the story of a small galaxy inside a vast cosmos that became the birthplace of beings capable of understanding both. And as the journey comes to an end, one final truth remains. The universe does not need to be small for us to matter. We matter because we see it, because we ask, because we wonder, because we dare to explore a cosmos that will forever remain larger than ourselves.